In this video, we will consider how the value of determinant is affected by elementary row operations. At first, let's consider elementary row operations, and their effect on the determinant of a matrix. There exist three types of elementary operations. The most simple operation is to interchange two rows in a matrix. In this case, the determinant changes sign. Let's take very simple example. Suppose 2 by 2 matrix is given. The determinant of this matrix is evaluated by the known rule. We first multiply the elements on the main diagonal, in this case we get 6. Then, we take minus of the product of the elements off the main diagonal. And in this case we get -5. So, 6 minus -5 results in 11. Now, we interchange two rows. Again, let's evaluate the determinant of matrix resulted after the interchange of two rows. In this case, we get -5 minus 6. So that comes out to -11. As such, we can see that the determinant has changed the sign after the interchange of two rows. And, this complies with our first statement. Let's consider the next property. If a matrix row is multiplied by some constant, then the value of determinant also should be multiplied by the same constant. Let's take the same matrix. We have already evaluated its determinant, which is 11. Now, multiply the second row of this matrix by -2 for the demonstration purposes. And compute the determinant of a resulted matrix. We get -22. This comes out to be a -2, which is a multiplier in this example, times by 11, that is the determinant of the original matrix. With this example, we demonstrated our second statement, which means that we don't need to recalculate the determinant after elementary row operations. And, in this case, it was enough to multiply the known value of determinant by a given multiplier. The third statement says that after adding a multiple of one row to another row, the value of determinant does not change. Let's consider the same matrix again. Its determinant is 11. Now, for demonstration purposes, we multiply the second row by a -2 and add to the first row. We get a matrix, where the first row is recalculated after the elementary row operation considered, while the second row remains the same. The determinant of a resulted matrix is 11, and is the same as the determinant of original matrix. Notably, no effect at all. We are already familiar how elementary row operations change the value of determinant, or do not. Obviously, the application of these properties allows us to save the computational time and reduce the probability of errors, which may appear during not actually needed calculations. Now, let's consider more interesting example. Suppose matrix A is derived from another matrix, denoted by a prime, after elementary row operations listed in the task. The row operations include interchange of two rows, a multiplication of a row by a multiplier, and the addition of two rows. The question is, what is the determinant of the matrix A prime, if the matrix A is given? First, let's compute the determinant of matrix A. One can observe that the matrix is upper triangular matrix. From the matrix algebra theory is known, that the determinant of a lower or upper triangular matrix, is just the product of the diagonal elements. Therefore, we get 24. Now, let's apply all properties we considered. First, the interchange of two rows changes the sign of the determinant. Next, we observe that third row was multiplied by 3. Since we want to get the determinant of matrix A prime, which was derived from matrix A, we have to take the inverse of a multiplier. Therefore, we get 1/3. The final one elementary row operation has no effect on the value of determinant. We combine all these derivations, and we get that the determinant of matrix A prime is -8. So, that's it. Thank you for your attention.